Assalamu alaikum. Welcome again. We will add error bar. In previous video we create average and standard deviation from 4 looms. Now we add this error bar, which is standard deviation. To do this, what you have to do, just click here and you can see this is chart title, chart tools. In chart tools you can see chart element. I am using Excel 2016. It may be different in 2013 or other, but 2016 it's very simple. Just click on any bar of your chart and then click add chart element. Then you will see that there's error bars, and if you select standard deviation, that I don't know why it takes a fixed amount of standard deviation, but this is not fixed. We have different standard deviation for different loops. So click on more error bar. When we click on more error bar, then it will show a fixed value 1. We don't need this. We need different standard deviation for different loop. So click on custom and click on specify value. What is the positive error value? This is the series of standard deviation first to 4 loom, and negative, this is also the standard deviation first to 4th loom. Now click OK. Okay, you have the bar plot with error bar. What does it mean? What does this mean? What this error bar means? It means that loom 1 has the average. Let me add the data level. I add data level here. Okay, you can see that loom 1 has the average strength of 95.50 with a standard deviation plus minus 1.29. This error bar above, sorry, just a minute, why it doesn't move. Okay, over the bar plot, this is plus standard deviation and this is minus standard deviation, same for all looms. So standard deviation is, we can see that error bar is length of error bar is the largest for loom 4, and we see that the loom 4 has the highest variation, and lowest is for loom 3, and we see that loom 3 has the lowest variation. So I think you could understand. Okay, now go to the problem sheet 1. We complete B and C. Now go to the 4th one, mean plot with error bar. This is highly recommended. I recommend it for we'll do this from same data. So I copy this and paste it. There is no calculation, so we can just paste it directly. So do the same thing what I have shown in the previous video. Insert, sorry, in a blank cell, insert column, no, sorry, we are going to create a mean plot. So create a line chart with a dot line with markers. Okay, I add this, select this, so select the data, add series name. You can just simply mean plot. Okay, this is mean plots. Okay, what is the series value? This is the average. We don't click the name, select the name, and we edit the horizontal category, which is loom 1 to loom 4. Okay, very good. We have the mean plot. Now we want to add error bar. So as we have seen in few times ago, go to the add chart element and click on error bar, more error bars option, and click on here. This is not fixed, this is variable because standard deviation is not same for all looms. So specify, delete this and select this range, again delete this and select this range and click OK. So this is the mean plot, and this is highly recommended. Don't use, try to not to use the bar plot with the error bar, because this is 84 does not mean that it doesn't mean nothing, but here we just show the mean. We don't need to show the height. This is not height, this is just a point, data point. If you want to edit this axis level, just follow this. We want to start it from 90, for example, say, or 88. What we can do, we just need to right button, click right button on it, and format axis. You can see the bounds, minimum is 84. We can set this as say 88, or maximum, it's okay, no problem. So the difference is more viewable and easy to understand. So I think you can understand the whole thing. Now go to the problem E. I don't want you to be expert in this. If you don't learn about ANOVA, you will not understand it, but this is relevant, so I want to show it. So just follow, don't be get bothered. The question is, are the looms similar in strength? This is a hypothetical question. It means that the average is significantly different from each other. Looms average, what I talking about. So I take the raw data and I go to data, go to data analysis and go to ANOVA with one factor, single factor, and we have no replication, just single factor. Click OK. My variable are grouped by rows because loom are in the row level, so I click row. Labels in the first column, no, I have the label in the row, so I don't click the column. So what about the input range? This is my input range. I don't need the 1 2 3 4. This is just identification of sample number. And I click in here output range and click in there to select where I want to show my output. Just click OK. What happened? Labels in the first column. Okay, sorry, I make a mistake. So this is our summary of ANOVA, that is analysis of variance. Who know what is analysis of variance can understand. There's output. Sorry, this is not time, this is a number. But there is something missing. No, nothing is missing, everything is okay. So you can see what we do in manually. This command give us the average, give us the variance, and you can compute the standard deviation. I have very little time in my hand. Just root over this and make it big and make it easy to read. I have 30. So this is the ANOVA table, and I just want to say if p value is less than 0.05, then we can say that loom averages differ significantly from each other. Okay, thank you very much. Assalamu alaikum.